Okay. So next we have Michael Richardson, who will be talking about designing IoT to be secure from day one. And if something that you want to know about Michael, that he gets his hands dirty, he's into coding, he codes everything that he standardized, and it's like, it's amazing. And also we asked him a bunch of good advice, like in our blogs, that what are the good advice that he has to people who are starting off. So if you have not read it, go read the blog on our iesoc.in/blog, and we do publish lots of interesting stuff there as well. So off to Michael.
Thank you. What? I can try? Yeah. I didn't put my name on this slide, which is kind of funny. The QR code leads you to the URL there if you want to follow away from home. So I'm going to be talking about IoT and kind of about security, and it's more about thinking in your mindset more than it is about protocols and code. So who am I? I'm a kind of a garage entrepreneur. I've been involved in a lot of .coms and this kind of stuff. It was a little bit of a revelation to me after spending 2 years in my first .com to realize I didn't have to work for the same company for the rest of my life. And it was a bit of a freeing moment when I realized, oh, I don't have to like everybody that I work with because I don't have to work for them the rest of my lives. And so that ensured to me basically coming and going in a wide variety of things. And my company is called Sandelman Software Works on account of the fact that I showed up at band camp when I was 15 and neglected to pack footwear. And therefore I had only sandals that I was wearing. And let me tell you, do not play soccer in sandals. Okay? So recently I work on secure enrollment, and this is a diagram from a couple of IETFs ago, and where basically made analogies between what we're doing in the large-scale operational ISP stuff and what we're doing at the IoT level, and I'll come back to this. I'm curious who you are. Maybe I can get you a show of hands. How many here are actively write code more than anything else? Oh, that's awesome. Okay, so running code, the first part comes before the running rough consensus, and sometimes we've forgotten that in the IETF, and I think it's very nice that we're coming back to it. How many of you write specifications primarily, even if it's specifications for someone's code, but for whatever reason you don't write code anymore? Okay, a couple. It's hard to admit that you may not be there. How many of you, I thought this was great, I found the many-armed project manager, Shiva kind of guy, how many of you would just classify yourself as primarily about managing what's going on in the world? And there's nobody. That's an interesting thing. They didn't come to this meeting. Okay. And how many of you are primarily in the management, upper management or something like that role? Okay, cool. I actually have a friend of mine that literally who looks like Dilbert's boss. And I looked a long time for an actual picture of him with his hair actually up like that. And we found one. Unfortunately, the contrast is too poor to tell it's actually what's going on. So I'm here to talk about, changing your view from, looking at what might be impossible things. And so don't look at the triangle too carefully. It will bend your brain, okay? Okay, it is an impossible object. You cannot build that thing. So let's talk about something that's possible. A cube. Right? Pretty simple, pretty interesting projection. Okay, you can think of it this way. Okay, I'll look at the front corner. Okay, so the cube pops out that direction for you. Okay, now look at the corner again, right? So it inverts itself, right? It's a nice illusion there that suddenly the cube changes, and it's the same cube, and it has the same dimensions and the same volume, and everything about it's the same, but you just flipped it in your brain by looking at a different corner, and that's what I'm asking you to do today. So exactly, I'm going to talk about what is IoT, because if I don't tell you what my terms of definitions are, then how can I argue about anything what's going on? And I'm going to talk a little bit about some of the verticals that I see and how this is kind of become a bit of a harmful red herring, if you like. Why is it hard? And then I hope to convince you that security is an opportunity rather than a cost. A previous speaker, one of his thought bubbles was, how can we afford the cost of IoT? And my response, I hope at the end of this you'll understand, is how can you not take the opportunity from it? So that's what my goal is, to do this. In searching for this, I found this lovely picture of poor Lucy, who has brought her roller skates to the ice rink, okay? And I think that this is sometimes what happens with people is they weren't quite informed about what was going on. They had a preconceived idea of what is going on, and so they show up, we're going skating. Well, you know what, that may mean something for some people, but for Canadians it means ice, and for other people it probably means roller skates. I should mention that I feel a special affinity as a fellow Commonwealth person, as a Canadian to India, and I also have a father who who essentially made himself a pest in Indian restaurants in London when he lived there. And so I grew up with him, an Albertan, cooking Indian food in small little town in New Brunswick. So I feel I had a kinship to you, even if I maybe don't have any actual kinship. So we're going, what is IoT? So lots of people go back and talk about the very first Coke machine, CMU Coke machine, and this kind of stuff. And it's remarkably hard to actually find a really good picture of that Coke machine. If you actually go on the internet and looking for the pictures of it, there are some, but they're really not very good. But in the process, a couple of years ago, I came across this Coke machine somewhere in Japan. And you got to wonder yourself, what's going on here? But more to the point is, what exactly it is. So this guy, Kevin Ashton, 99, who apparently is credited with having come it up, the way that machines communicate with each other in order to improve automation and efficiency in daily tasks. And it's interesting because the word human is completely absent, and of course he predates the cloud completely, right? So what is it? So I actually have three categories of things. The first category I call connected things. I have a smart watch. It's connected to my phone by Bluetooth. No V6, no V4, just Bluetooth. And I call that a connected thing. It can get data from my watch, my heart rate. It can go all the way up into Google Fit. My watch does not have an IP address, okay? This camera over here, this classic camera, okay, has no connectivity at all. It is connected to the internet by SneakerNet, okay, from 20 years ago. You pull the SD card out, you plug in another computer, and somehow your photos wind up on the cloud somewhere, right, in Flickr or something. So that is a connected thing. And then we have this great thing from 20 years ago, this QCat, which was basically a barcode scanner with a PS2 interface. And the idea was you were going to scan barcodes out of magazines. And this is a connected thing. It's not new. Connected things are not new. Every nuclear power plant on the planet is full of connected things. A whole bunch of sensors connected up to, yes, probably a PDP-11 because they're really that old. And that is a connected things. Those computers at some point, one of them is connected to the internet, whether it should be or not, and the data gets up there. It's not new in that sense. What's new, of course, is the quantity of it. So then I go to web connected things, and this is what and where I think we are in the IoT world. This is essentially the model of, there are sensors, they talk out, usually on port 80, and they talk to the cloud and they send stuff up. And the only way you can interact with them usually is to go to the cloud. A friend of mine, it's not a picture of his roof, but it's pretty close. He has a solar panel system, and there's a whole bunch of inverters that collect data on a minute-by-minute basis, and he can't get the data out of their device. He has to go to their website, and he has to scrape the data out of their interface. It's not even a CSV file. This is for his solar panels, right? He doesn't get the data that way. So that's a kind of a thing, but that's the kind of, as far as I can see, that's where we are right now. We are in the web-connected space. Internet of Things, however, that's when things talk to other things rather than necessarily the cloud. And we're just getting there. So Nest, for instance, has moved from being a web-connected thing where your thermostat data goes to Google and that's pretty much it, to now it does essentially Zigbee IP, or Thread, okay, is the next version of it, and it talks to your sensors in your home. And it doesn't have to necessarily talk to the cloud in order to do things. And that's the critical part where we're at. And this is what, when we talk, at least in the IETF, when we talk about IoT, this is what we're really talking about, an internet that is of connected things that talk to each other, not just to the cloud. So this is a big, internet, Industry 4.0 or industrial IoT has come along. And it's gone from a Coke machine. I did find a nicer picture of it. It's not as old as apparently, you can see there's Macs in the background. So apparently the Coke machine really does predate that kind of stuff. And if you've had any contact with GE and what they're doing, essentially they've hooked up all of their turbines to their cloud. They collect vast amount of sensor data from it, and they do things with it. So this is their vertical, right? Their business plan is collect data, send it to cloud, or first step, add sensors, send it to cloud, do some magic big data optimization, and figure out proactive maintenance, how to optimize the system better. And there's a real return on investment from what I gather. And they have, from what I understand, essentially gone from producers and sellers of turbines to sellers of power. So because suddenly, if you're doing all this data collection and all this kind of stuff, it becomes in your own interest to do the maintenance too. And so they are no longer, in many cases, selling turbines. And I understand this goes into aircraft engines as well. They're no longer selling you an engine. They're selling you power. And you'll pay a certain amount, and they're taking a cut out of how much more efficient they can run it than you could, from the fact that they have data on thousands of turbines and you have data on 2. So I was at another conference a few weeks ago, and it was in Belgrade, and one of the things I was kind of surprised to learn is the extent that those lands, the Balkans, are still quite relying on coal and this kind of stuff, and the rest of Germany's all green, but Serbia is not. They have a serious pollution problem. So one of the things they did apparently recently is they put pollution sensors on their fleet of buses. The buses wander around town, they collect data, they get a GPS map of where the pollution is, how bad it is, how it's going, and this kind of stuff. It's a pretty simple, straightforward IoT play. It seems very effective. It seems to really have caused some real political progress on doing things. They're not over yet, but essentially they built web-connected things. It goes up through, the slide said GPRS, I asked, and the answer was yes, it really was GPRS. It wasn't LTE. It was, the cheapest thing that we could get to do it all. And then these little probes that go on the top of the buses. So what's the story so far? I promised you security, right? But so far I've talked about what's what and who's who. The key thing I've talked about so far, both in the case of the Belgrade bus system and GE, is that was vertical, okay? And one of the key things about verticals like the GE is they don't really have customers. They don't sell their products to anybody. So that's pretty subtle, okay? Because, just go back there, because if you don't have customers, then all of your costs are internal. What matters at the end of the day is, did you make money in your whole system, or did you do your public activity? So if you need a certain amount of security, you'll make that decision, you'll do it, and you'll provide it. And if there's a cost, well, you'll eat it. But more importantly, you don't have to interact with anybody else in order to build your security or any of your system. You don't need to do, as our previous speaker said, you don't need to do any standardization. You're the only person involved, and you can go and figure it all out and do your thing. It also means that if you want to provision long static keys and use one DES, and your analysis says that that's okay and that the devices will be dead or out of battery before you have to change the keys, then that may be a completely reasonable security analysis to do, and maybe that's fine. And maybe if, the pollution data is public anyway, you don't need to encrypt it anyway. But what if someone challenges the accuracy of the data? So you may want to have something to do with it. But again, that's your decision, okay? When you have customers and you have to interact with other people, and there's other things, suddenly it becomes an issue. Suddenly you have to do something. So, for instance, what if I would like my heart rate monitor, my pacemaker, to interact, and the slide didn't work too well, to interact with that pollution system on the buses. So I'm sitting on the bus and suddenly I have difficulty breathing, okay? And my pacemaker says, hey, you might be having a heart attack, something might be going on, right? Would it be interesting if my mobile phone that's collecting all the data on me, for my doctor, could ask that little sensor, that bus sensor, is there a lot of pollution right now where we are, right here? Because that might really be an interesting thing to say, yes, you are having difficulty breathing. No, it's not a heart issue. It's an air issue. You're having an air breathing issue. If you would just go where there's better air, you'll feel better. You don't need to go to the hospital. You need to get better air, right? So that would be a very interesting thing to do. And I tried, and I actually asked about 6 of my Indian friends, what is the Indian word for matchmaker? And I got a bunch of different answers, and none of them are good. And if we were in Russia, I would pulled out Yentl slides or something, we would have done something else. But what I want to do is I want to marry these two devices somehow and have them ride a nice elephant down the street. So how are we going to do that? That's the question. And that's I think, the real challenge in IoT and IoT security, because, well, there's a whole two verticals of marketplace that have to do. Push the right button. Nope, that's the right button. So that was the slide. The bus, my pacemaker. Why is it hard to do this? Well, I mean, this is our goal in IoT. It should be, pretty easy. And it's difficult because there's essentially, there's two verticals. There's an entire medical industry vertical. And in this case, there's a municipal bus thing that they didn't have any standards. They just did whatever that made sense to them. So what do you really want? You want things connecting to other things, not just things connecting to clouds. And that's the challenge, okay? And that's why it's hard to do good security in an interoperable fashion. So, some people think, okay, it's fundamentally the problem is I work in enrollment standard specifications. How do I get the network keys into this small device that doesn't have a keyboard? So that's a pretty difficult deal. That's a hard problem to begin with, okay? And that's what we're working on. Authorization, well, who can do what, right? In the bus case, am I allowed to inquire about the pollution level? Am I allowed to inquire about the location? Am I allowed to change the settings for where it sends its data to? So the answer is probably yes, no, right? Well, what other models can we do with that kind of environment that would mean maybe I don't need authorization? There's some interesting hacks. For instance, what if the bus pollution thing had a Wi-Fi? It was part of the municipal Wi-Fi effort that was on every bus anyway, and I could just listen to the Wi-Fi and the pollution sensor would simply broadcast the value. No requirement to have authorization. It's just telling everyone every 30 seconds what the pollution value is. And that's an interesting model. And one of the IoT guys, the IETF, who was chair for a while, he had the model that, you can just do this. And he had built these little sensors that he distributed around his house. And literally an 8-bit microcontroller. And it just transmitted the temperature to a multicast address, a V6 multicast address, every 30 seconds. There's no configuration possible. It didn't do anything. And like most of the packet came from ROM. Okay, it just transmitted it, just put 16 bits in the middle of that packet, changed it each time, recalculated a checksum. Actually, I think he didn't do checksums. So, and it just sent it. And it was that stupidly simple to do that. Well, it doesn't work everywhere, but it was an interesting hack. How stupid can we make this thing? So let me ask the question again. Who types in the Wi-Fi key on your laptop? If all your hands don't go up, then you probably haven't done it, right? Okay. What about authorization? Who is allowed to type on your keyboard? Who decides that? I hope it's you, right? Or your manager, right? What about those pesky firmware updates? You decide, I hope, that you don't do firmware updates in the middle of the presentation, right? Maybe you're forced to do them by the end of the day or something there. So that's an interesting point, okay? We have to essentially build a human into every single IoT device with all the judgment of what's going on. And that's not so easy. And your thermostat, who could own it? Which human are we going to build into it? There's a whole bunch of choices, okay? And I bet you that 90% of the people that have smart thermostats in their home don't know which one of these are actually active. If I bought a new home, I've owned one for 17 years and I'll probably never ever move because it's too much hassle. If I bought a new home and it had any smart devices, a condition of sale would be you rip them all out and I get analog. Okay? Because I don't know what you got. I may rip out the analog and put my own in, but I don't want to cope with someone else's bugs and other stuff. When I got my home, when I bought it, there's a ceremony, I'm sure it happens in India as well, where you go to the lawyer's office and the lawyer gives you the keys that they received from the seller. And you go home, or to your new home, you remove all the locks, you go to the hardware store, and you have them rekeyed. And then you throw away the keys the seller gave you, and you have your new keys, right? So in a smart home, you have to do that, right? We're going to have to do that. That's going to be a problem. And if you aren't doing it, and if your product isn't capable of doing that, then you have an issue, right? Because you're going to have to do what I'm going to do, which is you're going to throw them all out, and that's not so great. So one of the things that we're saying is, well, look, this all has to be automated. And that was just the first point, what is it hard? Wi-Fi keys. This all has to be automated. In a working group, an IETF working group called ANIMA, for Autonomic Networking Integrated Model and Approach. And as for the question at the microphone, the most important thing is you have to come up with a cool acronym before you publish your draft, okay? One of the things that I'm working on is a protocol called Brewski, which is the bootstrapping remote secure key infrastructure. And essentially, it allows a device, in this case the ANIMA target is actually big ISP routing devices. We want to be able to essentially ship them from the factory unconfigured, have essentially minimum wage workers install them into the cabinets, turn them on, and magically the owner will get control of the device if the cables are even plugged in at all. Not correctly, just if they're plugged in. Something's plugged in, we'll get some connectivity. And you do it. So that's part of what's going on. And I just want to, I put a little box there about an old RFC that I worked on many years ago, which never got any traction. And it was called the Simple Public Key Infrastructure, SPKI. Ron Rivest wrote that draft. And I really encourage anyone who has any interest in security to go read the document, not because the concepts and the protocols we designed were at all relevant or got any traction, but because we came up with some really good terminology and some other realization that all trust is essentially local, okay? And that's an important thing. The device trusts what anchors he has, and that's a critical point to going on. You don't trust other parties. You trust yourself, and then use digital signatures to trust other things. And that's really a powerful, powerful thing going forward. So Brewski, I'll talk a little bit about that, and a little bit why and how you could use Brewski for a profit. So we have a pledge. It's a duck. There was a paper in 1999 by Ross Anderson in the UK, Cambridge, called The Resurrecting Duckling. And it was actually pointed out to me, this document, when I started talking about Lorenz and biology and how ducks actually imprint on essentially anything that looks like their mother. And it turns out I wasn't the first person to come up with that idea, that Resurrecting Duckling actually talked about that as the model. And so we realized the new device had to be a duck. And it's called a pledge after the fact that if you join a sorority or a fraternity in university, they initially accept you on a provisional basis, and you're a pledge, and there's lots of really bad movies you can watch about things pledges have to do to get ahead. The second aspect we have is the manufacturer. And the manufacturer, we created this acronym called the Manufacturer's Authorized Signing Authority. And the reason we have such a complicated thing is because we recognize that in many cases the manufacturer is going to outsource this activity. But essentially this is the manufacturer saying, I designed this device, I have left an anchor in that device by which that device is able to validate me as the manufacturer. And so I have this nice little animation of this construction vehicle building stuff. Finally, we have the joint registrar coordinator. Originally just a registrar, and then there were some other issues it had to do, and it became a joint registrar and coordinator, and does some other things, and the coordinator aspect's not relevant for us today. Sometimes just a registrar, and the best symbol I've come up with is essentially a customs guy. The registrar is the representative of the owner. So if this is a device you're turning on in your home, it's you. If this is a device that you as the municipal transit authority is turning on, then it's the municipal transit authority. So it's whoever is receiving the device is the registrar, and they're the thing accepting. And they have two problems. One, is this the real device? Because they may not be physically seeing it. Okay. And two, how am I going to convince this device that I'm its owner? So finally, we have a thing called a voucher, which is the only one that's at this point got into RFC 8366. And that is a digital statement from the manufacturer. Oh, did I miss a slide? Yeah, it's the next slide. It's a statement from the manufacturer to the pledge saying essentially who is owned by you. So the device gets manufactured, it wanders down the nice little road from the mother ducks, it gets to its location, and there's an interaction there. And in that process, a voucher gets created, and it says, you're owned by this guy. Here's the better diagram. No, I'm missing a slide. There, no. I wonder where it went. There we go. Okay. So essentially this is now there's an interaction that happens, and there's some back and forth and there's some other stuff. But fundamentally, okay, what happens is that the new device says, hi, I'm the new device. You look like you might be my mommy. Are you my mommy? And the registrar goes off and speaks to the manufacturer, and the manufacturer issues them essentially adoption papers. And the adoption papers come back to the end device, and the device says, oh, it says that you're my mommy. Isn't this wonderful? We now have a relationship. All of this happens over a TLS connection with client certificates, which are pretty uncommon in many places, and server certificates that are relevant. And the ultimate end result of this process is that the new device has a cryptographic statement from an anchor they already trust, the manufacturer, which they were built with the knowledge of. That's why the little duck's thinking about the signet ring. He says, oh yeah, I remember my guys that build me. And that statement says, you may trust this public key, which you saw in the TLS connection. So the two things, and I thought this had a pointer, but I guess it doesn't. The two things between the registrar, whose picture disappeared, unfortunately, I noticed this morning, and